Okay, so delete this input power supply like that. Okay, because you can't build a circuit with a power supply, right? Okay, so you're only manufacturing a circuit with lines. So what you need to have is a terminal to connect the wires to the power supply. So the terminals is placed under connectors, I believe, and then it's going to be terminal blocks. See that? Okay, so I'll do that again. So this connector, this icon here, next to on the right hand side of the blue icon called place connector, and then select terminal blocks on the left, and then I don't always remember the model number, but there's a -2. -2 means 2 inputs terminals. So press OK and place it here, and then what you need to do then is to wire your, like if it was a power supply, to here, and then your 2, be careful, it's got to be the diagonal corner, okay, like that. Okay. Look, if you make a mistake, don't worry, just watch the video again, but because what I wanted to do as quickly as I can, just show you this, then you can get on with it. Then I can take some of the students downstairs now to finish off their measurement of the 19A, so I can set up the instrument for the 19B, the digital circuits. Okay, right. I also need to connect my oscilloscope to the output, yeah? So therefore I need another terminal blocks on the other side. So I need to generate another one, also 2 ports, and press OK again, and then just place it here. And what I'm going to do is I'm going to rotate it like that. I'm just going to shift things on the left hand side for now. Okay. And then I'm going to place it doesn't matter which pin you go for, so it's the terminal block is just 2 ports. So you can have P2 connecting at the top, so it's not positive or negative really. So, okay. And that allows my oscilloscope to be connected to the J2. Okay. So oscilloscope at J2 and also power supply at J1. So you got power coming in and then measuring output on the J2. Okay. So that ways you don't have to clip. You don't need to clip your oscilloscope onto the resistor because it's all soldered on. So therefore you should be doing it properly with a terminal blocks. I mean, imagine your laptop, yeah. If it doesn't have a connector on the side, instead you are asking you to clip onto the circuits. That can be dangerous. Yeah. Okay. That's almost it. Why I say almost it, I'm going to show you why. So if you go to transfer, or save it first, sorry, save it. So go to transfer and transfer to Ultiboard. You should get an error in a moment. Okay, so I'm just going to do that now. Okay, so component with no package will not be exported. Okay, so we're going to say no to this in a moment. So what do they mean by no package? Because at the moment, I'm using a generic resistor. They don't know if this is a surface mount resistor or a through-hole resistor. And we are using through-hole. So therefore, we need to tell what package this is. So that means what I need to do is double-click on the resistor and then go to, let me just double-check which one I should be using. Yes, you see, on the value, there's an edit package. Select from database. There you go. And you can find a through hole. Can you see where it says TH? Okay. Usually that will be a through hole, but be careful. There are different types of through holes. So, so you got to look at if you've done your report right in the unit 2028, you have understood what I'm showing you now. If you haven't done a distinction report, you have no clue what I'm talking about. So therefore, you got to look for a package that looks like a through hole with two holes. That is actually a surface mount. Okay. So such as this one, this is perfect. Okay. That is what I'm looking for. But you can see some of these resistors have multiple resistor in a chip. Okay, you don't want those. So let me see which one I usually use. Okay, and then everyone can use the same one as mine. So normally, just bear with me. I'm just going to look for that now. You see, all this package, some of them are nothing to do with the resistor. So what I would suggest we do, if you just give me 1 sec, just watch what I do first. I'm just going to place another resistor. In this case, I have a 36 ohm resistor. So I'm going to go back to the normal resistor, generic one, and then find a 36 ohm. Okay, like here. 36K, so 36 is here. Now, underneath here, those package by default are good. They are the ones that we normally they are the ones that are through holes. So if I just pick on the first one for now, and then press OK. So IPC 2022 1A. So, and I'm going to replace this with the one that I didn't have a package. Okay. And similarly, I think we need to do that for every individual one. So we got to go back to the capacitors. So in the future, when you do a circuit, you might as well put a package in at the start of your schematic. Yeah. So we're doing it in a sort of amateur way. Okay. So go and find your capacitors again. In the place basic, and then it's an electrolytic capacitors. Because it's such a big capacitors, you can only use electrolytic capacitors for 1000 microfarad. Now you don't have to use 1000 microfarad. You can use 470 microfarad, because some of you have used a 470 and it also stabilized the voltage. You don't actually need to use 1000, and that I think there's only about 1000 microfarad downstairs, so it's not going to be enough for everybody. So go for 470. I think there was a 560 as well. So use those. Okay. But since they're the same package anyway, it doesn't matter if you swap from 1000 to 470. It wouldn't affect your circuit. Okay. So I'm just going to pick my 1000 microfarad, which is 1M. 1000 1M. Okay. And then again, pick your package. I always pick the first one. Okay. So press OK. It looks like they're all IPC-2221A. So we'll see if this will work. So Control R just to rotate that, and then delete this. So Miss, I think when you do your when you are with your year 1, the year 12 class, just make sure they add a package beforehand. Okay. Okay. Now the diodes. Okay, so we're gonna go, so if anyone use a 1N148, you now need to make sure you're not using 4148. You can use 1N4001, 402. I don't know if I have 403. Did anyone remember if I have 403 in my okay, so maybe 404 I don't have. Okay, so anyway, there was one that we didn't have. So anyway, so we go to the diodes, and I mean, if you go for 401, there will be no problem at all whatsoever. So if I go for 401, and then already, look at this, it's already got DO-35 in it. Okay, so the package is already chosen for Motorola. Okay, now I reckon maybe this has already got a package as well. So let me see if I got a package already. Yep, I already got a package with that. So I don't need to add any more diodes. So I'm just going to delete that again, sorry. And which one do we have left to do? I've got a C6V2. This one is definitely a brand. Look at the package then. I don't think this is a through hole. This is a surface mount one. So we'll leave it. I'll let you change that in a moment to have a go at finding a through hole version of this. Okay, and we need to change the resistor now for the 1K ohm. Okay, so let me see if I can find it here since it's all IPC. So there should be an IPC H. Nope. Okay, that is IPC, that one. That is IPC 2118. So let me see if I can find the same manufacturer. I think, guys, the easiest way is to actually change the resistor, because all these are not specifically for the resistor at all if you go and edit the package. So I'm going to just delete this, it's quicker. So delete. Put the 1K back in there. So go to resistor and put 1 kilo ohm. Scroll to 1 kilo ohm. Yes.
Do you know the manufacturer of the xenodiodes that we have?
No, because they are not a company that you will be able to find on the thing. So you just have to find a package having the same footprint, which is a DO-35. Or go online to find the dial and look at the package, and then find the package on MultiSIM that relate to the same model. So in this case, for this one, yeah, I mean, for the dial is DO-35, so it should be fine. So if I go and quickly search what the DO-35 looks like. Yeah, there you go. Actually, this is not quite the one. This is the smaller one. The one we are using is the black one. They're slightly bigger. These are low current. That's why they're smaller. So because that is a DO, what? That's a DO. Sorry, 1N403. So if I go for a 1N. Yeah, it's probably okay. It's probably okay. You just have to make the holes. Yeah, it should be alright. It should be okay. They should be the same footprint. Right, ladies, please. Okay, right, let's have a go now. If you have changed all the settings, so they all have a package now, and including this already by default has a package already embedded. So this time, save it again. And then go to transfer Ultiboard. So when you write your report, you need to screenshot some of the things that you changed, okay? The packaging, explain that you need to change the package first. Now, hopefully, this time it has no error and takes me to the Ultiboard straight away, which I think is happening already. Okay, so it just gives you a list, what we call a net list, okay? A net list. And the net list is basically verbal instruction of which pin is connected to which component, and they're called net, okay? So, press OK, and then I'm going to zoom in here. Look at that. I'm happy with, apart from one thing. I'm happy except for one thing. Do you see, anyone see, Jodie, please? Which one is a problem? Which one is not the package I'm looking for? D5. Look at that. What do you think that is? That is a surface mount. So we've got to go back to D5 and make sure the D5 is the correct through hole package. Okay? But looking at the other ones, I'm really, really happy that they are the package I need. Okay? So, we're nearly there, guys. So, let's go back and close this Ultiboard. Don't save it. And then we're going to go back to the MultiSIM and look for D5, which is exactly what I thought it would be, the center diode. Okay? So, how do I go about this one? I'm going to go to Google and search the center diode that I intend to use. If you remember, the center diode was black with a white stripe or silver stripe, so I guess it's a DO35 layout as well. So what we're going to do, so can you see if you can Google search a center diode? So a center diode. And if you can remember what voltage your center diode is, so if mine is 5V3, I type 5V3, okay, and mine is a 1 watt. I bought 1 watt diode for you guys, so it should be that type, yeah. There you go. So this one tells me it's a DO41, okay, package. So I need to find a diode with a DO41, okay, to match with this. All right? But if you think your diode looks like this, your package is a DO41 as well, okay? So DO41 for all of them, but not a surface mount, which is a SOD. So the one that I just had looks something similar to this one, okay? So let's see if we can find so James was asking what's the manufacturer name of my diode that I bought. Because they were made in China, they don't have a manufacturer name. Okay, that's why they're so cheap. Okay, so therefore I suggest if you go for Motorola, you can't go wrong, because Motorola basically make all of the semiconductors that humanly can find. Okay. So MultiSIM wouldn't have, you know, on Sammy. I've never heard of this brand. I think this is quite a new company in the last 15 years perhaps. So all I'm saying is you need to find a DO41 oh, there you go. BZ6. Look, BZ6 85C. So if you find that on your diode, so let's go back to that. So let me just jot this down. $85C. Now hopefully the MultiSIM has this particular one. So we're gonna go and search for a center diode this time. and then scroll down until you see BZX 85. In this case, 85. Yep, got it. And then let's say I want a 5. Oh, I don't have 5v3, so 5v6 maybe. And then look at that, DO41 by default. Yeah, use that. Okay, so I'm gonna remember this, and make sure you remember to use this model number for your center diode. Save you loads of headache. So let's delete that one and replace that, and then join them up again. Guys, I think this is it. This is it. Okay. Is there any question up to this point? Rashan, can you pay attention, please? Thank you. All right. Okay, so one last chance. So save the work again. Transfer to Ultiboard. And then save it again. I will overwrite the file. So again, no errors. This time, look at my net list. Okay, but a word of warning. Your diode, center diode, looks similar to the other 4 diodes. So make sure you know this is your center diode and it must be working in reverse bias situation. Okay, so happy with that? Now I'm going to screenshot this, and then I'm just going to quickly put that in the Teams. So then hopefully, if you get the stage right, you will have something similar to, well, you should have exactly the same as mine, okay? Because MultiSIM like to align them in smallest to highest, biggest component. So hopefully, so just need to look for a print screen button now. Where's the print screen button on this one? Doesn't look like there's a print screen button on mine. Oh, there it is. Snip. Right, here we go. And then, have I got Teams already? So I'm going to put this in unit 22 CD for you. So unit 22 CD, first look at Ultiboard for your full wave rectifier. Okay, so it's there now. Okay, so what do we do next? The next bit is quite enjoyable, only because there's only, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 components, okay? Imagine you have to do this 1,000 component, but that will be one day AI's job, okay? So for now, all you need to do, the first thing you're going to do is to make your board smaller. Okay, I remember I gave you this activity before to how to change the board smaller. Now, can you see, first of all, it's in different color. You got light blue, dark blue, yellow outline. That's because they are in layers. Just like when you do your CAD, you're using layers. So what I tend to do, if I want to change the board, I would disable all of the layer, and then so then I'm not selecting them, okay? So normally, so it's on the button here, enable selecting areas, okay. Enable selecting parts. So you need to delete this, delete the layer except for the board outline, okay? And then you should be able to select the board outline and actually drag it smaller. So let me try that first. Okay, so we need to highlight board outline, so then it knows that we are selecting this. There we go. Okay, so put your cursor, okay, and click on the board outline so it's in red, and then drag and drop where you want it, the board outline that you want to select, and then you can see it's been selected. And then now you can shrink, you can then change this board, making it smaller, I believe. Okay, there we go. And just zoom in there. Oh, it's actually moving my shape at the moment. Okay, let's double click on it. Okay, guys, I've decided to double click on it. Okay, now, because National Instruments is a American company, that by default they will use imperial units. So I would suggest you guys to either go to the global settings and change everything to millimeter, so you're always working in millimeters. Okay, so that's what I would do. So I can then manually change the board size. Now, 10 component, you can decide what size you want to do. Okay, so can you roughly think about what size a 10 component is going to fit in? Okay, and then you have to, in your report, you got to write down why you use such a size of a board. What's the benefit and cons? You know, maybe cost saving. But if it's too compact, then the hotter component might get too close, or you get more interference with the electromagnetic interference. So you got to balance that out. And I don't mind what size you use, as long as you write down a reason why you chose that size. That would be good enough. So I would just go for, let's say 60 by 60. I just want to use a square type of board, like so. There we go. Now, in comparison to my component, now it's a good time now to put my component inside my board. Okay, so you can see, in fairness, I still got space in my board, but that's just 6 centimeter, guys. All right, so 6 centimeter is this much. Okay, so you know, if you use less material, I get more PCB left for next year. But looking at this, I think this is a sensible one. I would probably go a bit smaller, okay, just to make it more compact. I have students only use about that amount, okay. But again, he or she justify the reason for that, okay. But you can change that later on. So you can just keep this like it is, and now work on what we're about to do. Okay, so hopefully you got this circuit in front of you and you can play around. Now your job now, it depends how quickly you can do this, is to make these yellow lines never crisscross. Okay, these yellow lines here cannot crisscross. If you can achieve that, you've done your 90% worth of your work, okay? Because that is the hardest part of it, okay? So I'm going to give you 10 minutes to have a go, if you have this in front of you, to make this not able to crisscross, okay? This is only 10 components, okay? I can guarantee you there are multiple ways in which they do not need to crisscross, okay? Now, my previous year students used to ask me, sir, what if it's impossible to crisscross, to stop it from crisscross? What would you do? And then someone else in my class answered that question. What do you think? If we cannot solve the solution?
Multi-layer.
Multi-layer. Yes, use a wire, take it down underneath. That's it. Or jump wire. You know, you saw it from my television PCB, which has a lot of silver wires. That's kind of like what we call jump wires. Okay, right, let's have a go. And making sure the yellow line do not crisscross, yeah? So, I'm going to spread the component slightly away, like this. Immediately, look at my R3. If I rotate this, look at that. I sort out majority of the problem. Now, looking at this, this is to there, right? So maybe I could do it like this, even better. So you can see, look, if you move it, it works. There you go. So I solved that problem straight away. So do you see? So spread your component slightly out, rotate your component, so then you start to see the methodology in this, okay? Now, remember what you wrote in Unit 22A. You said the connectors should be on the edge of the board. So let's see it. Show and tell, right? So make sure in the end, I want to see a J1 on the side of your board, J2 on the side of the board, okay? But for now, let's see if you guys can get this component all sorted, okay? So I'm going to be quiet for a moment. I'm just going to work on this while this is still recording, okay? Do not copy me because it's more fun if you find your own solution. And also, I may be too fast for you anyway. In fairness, if you follow how you did your circuit schematic, it should do it. So I would probably do the, you know, the rhombus version with the D1, D2, D3, D4. Okay, it should line up nicely. Okay. Also, I had students in the previous years. They said, "Oh, sir, the D4 is flipped up the wrong way." So then they manually flip it the other way around. Don't do it because it needs to be reversed. If you remember how you make your antenna, all your masts need to be in reverse. So when it get ultraviolet light exposure, it will be corrected again. Okay. So don't manually change the letter back to normal, please. Thank you. One, two, three, four. What time do you call this? Jeez. Of course you do. Also, guys, when you start moving your circuit, the computer automatically readjusts another combination of the yellow line. So sometimes you might think the yellow line is crossing, right? Actually, if you move it to the other corner, it will find another way to sort this out. So therefore, you just have to keep playing around. Okay? Look, when I start moving things, Have you managed?
No, I haven't.
Oh, I thought that was quick.
I need your help.
R1 there. So R1, capacitors, Zener diode. Oh, where's my little resistor gone? So 36 ohm is R3, so I need it to be horizontal maybe. There we go. And then that will stop.
Yeah, in this thing, it's vertically.
Yeah, the terminal's sticking out both sides instead of one side.
Yes.
So I've done all the placing, but I need to go and redo the whole thing.
That is what I was struggling with.
Yeah.
Last work experience thing.
Right, guys. I decided that the way that I'm arranging my circuit is getting really long, so I'm going to make that more rectangular in shape. So that's, and then I write in my report my refinement, the reason why I do that, because I'm trending to be a long circuit rather than a full square. Okay, reducing space. Well, guys, look at that. I'm nearly there. I'm nearly there. I think I actually have the answer now.
So,
Although that is crossing, but you can go up and across, you see? Yes, hello, sir.
only one problem. The capacitor has the pins sticking out both sides, as opposed to one side.
Capacitors. This one.
Yeah.
Sticking
It has
out.
one pin going out the top and one out the bottom. And it's the same if you look in 3D view. So you need to change the package.
Really? What package is that? So transfer. So let me see. View, 3D view, bird's eye view. Let's have a look. Oh no, that's not bird's eye view. It's a 3D view. Okay. What's the problem with this one?
That's not the right capacitor. Is it too big?
Yeah.
Sorry. Repeat what you were saying. What's the problem with
So
this?
the capacitor on Ultiboard has a pin coming out either end, but the capacitors you have downstairs have both pins on the same end.
Yes, because it's standing, isn't it? True. Yes. Yes. I okay. All right.
So that needs to be
So what? Okay. In that case, but is that the same for 470 microfarad though?
I would think so.
Yeah, all of them were bending for the legs, didn't we? Yeah. Okay. So so we double click on the footprint. And then I wonder if we can manually change it here. No. Footprint. Change. Package. Change. Can I change here? Yeah, we have to change it from the project's component.
So, I found the best way to do it. If you
Listen, I tell you what, we just see who's distinction and who's merit. Let's see if they figure this out themselves. Yeah. Okay. Yes.
if you double click on this, you can see a visual
I know, but
and just scroll through it until
I want to change it without going back to MultiSIM, and it's possible because on the bottom, can you see the parts here?
yeah.
You can actually change it here. You see? So, just for my distinction students, if you haven't missed anything, so this is not the capacitor footprint that we are using downstairs. If you have done measurement, you have agreed the pins are not coming from the side of the capacitors. So you have to actually change the footprint of your capacitors. So again, let me show you what I mean by that. So 1000 microfarad capacitor. So this is the footprint we need. Okay, guys? It coming out from the bottom. Okay, like this. So we need that. However, you might say, sir, I'm going to keep it like this. I'm just going to bend the wire and then just slot them in there. It's fine, but you're using the wrong footprint, which might cost you a distinction. So if you can find the correct footprint, and I can tell you, it is in there, and it's circular. The footprint is circular with one of the pin square showing positive, and the footprint for circle is a negative. So positive, negative, yeah? Okay? Now, guys, I have done it. This is it. I have nothing more to do because I have connected everything that I wanted. Okay? However, you may agree that, sir, how can you possibly, this is crisscrossing, so how does this go in through there without crossing this diode? Well, what a silly question, isn't it? If I push that in, yeah, and then now I'm sorted. Now I can go round and then go across, couldn't I? Okay?
So
Yes.
once you're all done, with a
Yep. Just one moment. Let me just tidy this up. And guys, is there a problem with this one? Do you think there's a problem with this?
no.
This problem, is there a problem with this? It's going through the diode, doesn't it?
The die's going
Just do it on the other side. BCB.
Well, the thing is, it just go through the symbol. It won't cross the track. The track is from there to there. The track is from there to there, so you can go through there. Okay, so we're sorted. It's not crisscrossing. So we're good. We are good, guys. So I'm done. Okay, so this is my final screenshot. I'm not going to refine this. I'm giving you a slightly rubbish one, and you can finish off yourself, because I see a lot of people using phones, so I would just finish off quickly and then go and do something else instead. Okay, so my final footprint, unrefined. If you copy, you get a pass. So, has anyone found the footprint for the capacitors?
I found I found a good footprint. It's
good footprint. Okay.
I don't know if it is the right
Okay.
manufacturer. It's CAP double P R 350-800X 1150.
Sounds good. But likewise, I just go back to here and look at the footprint here. So I need to click on it. Oh, maybe this brand is quite common, Nichicon. Let's see if it's in there. So on the MultiSIM, go to the capacitor, that one, and then placing, yes, okay. So looking at this, do I have a cooperate database through whole ones, and then look for capacitors, and it's gonna be called a electrolytic. Yes, there we go. Right, question is which one? Definitely not those ones. That is a good one. I think they are measuring in radius. The diameter is 25, so I need to find one that is quite large. Leco 5. Footprint specifications, footprint or package, dimension is 25, 12.5, 25 millimeter, so 12.5, something to do with 12.5 maybe, 12.5, oh no, radius is 5, so I need to find the radius for this. Radius is 25 millimeter. 25, I reckon these are 25 millimeter. I think they stand for 25 there. So let's look for something that is slightly larger, maybe 5R, 25, 25. Let's go with, yeah, let's go with that one. So I'm assuming that's 25, unless that's 25, no, yeah, so 25. Okay, now I changed it. Oh, now we have a problem. The net, oh, they get rid of the connection, but that's okay. We can manually draw them ourselves. But don't know what this red thing does. I think it's just strange. Okay. So guys, you need something similar to this for the footprint of the capacitors, because they are that type with 2 legs from the bottom. Okay. Okay, so the last thing you need to do is to draw your tracks. Okay. So for distinction students, please look here. The width of your track determines how much current it can take. Now, can anyone remember the maximum ampage, the current for the power supply that can produce? It can produce 6 amps. So therefore, you need to work out what is the width. So the best way to do this is to do PCB track width calculator, and then go to the track width calculator, whichever website you want to use. They are basically the same formulas, whichever you prefer. So here we go. So the current is likely to reach up to 6 amps, and the thickness of your copper is actually half an ounce, but let's just put 1 ounce in for now. I just usually keep those temperature rise and trace length by default. Your track length shouldn't be longer than 1 inch long, and then the required trace width, I think it's already by default is working this out for you. So change that to millimeter. It says you need a width, external layer, you need a width of 3.56 millimeter. Your track needs to be 3.56 millimeter. Otherwise, your track will start to get hot and it might become brownish color because it's going to be burning. So 3.56. So I screenshot this, show my examiner that I have used an appropriate calculator to evaluate what sort of width I need to deal with. So just to prove my point, if you reduce your current by half, your width will reduce also. Okay? So that is why your laptop circuits, the track width are so narrow, is because they use 1 amp current throughout the design of the electronics. Okay, but because a rectifier works with a power supply, which deals with high current and high voltages, so normally the width should be quite wide. Okay, so now bear that in mind. It's 3.56 millimeter. So I'm now ready to create my trace width. So my trace is to draw using one of those lines here. So first of all, select the right layer, which layer you are trying to draw. So you are going to draw on your silk screen. Silk screen. So there should be silk screen bottom actually. Because the track should be on the underside. Okay.
Not copper bottom.
It could be, but at the moment, the only way I can find out sometimes is to press print and then only enable the layer you want to see. So if I press print, yeah, there are still errors. Don't worry about that. So if I go copper top and press preview. Okay, so you can see, you only see the soldering part. Okay, so that means copper top. So it's actually, we need to do it on the copper top, by the way, copper top. If I if I enable the copper bottom, and then take the copper top away, still the same. So seal screen maybe. So project layer file print. Yeah, so let's go for, I'm gonna draw it. It doesn't matter which side you're gonna draw. I'm gonna draw it on copper top. Okay, so I'm gonna make that my active layer, change that to my millimeter. Okay, and it says automatically drawn using 0.254 trace clearance. So let's just draw the first one. So trace, draw trace. I think it's this one. I think. Let's see. No.
Oh, yeah, Jordy with the first two.
Okay. So it's the pencil button here. The pencil button is to draw the tracks. Okay, so I'm going to draw the first one. Can you see, once I've done the tracks, the yellow line disappear. It shows that you are joining it up. Okay. However, you need to make sure the track width for all of them to be 3.54. So I need to change all this to be 3.54 millimeter. Okay, like that. But you can see now the track width is bigger, is wider than your component's footprint. So you have to also increase the circle. Okay. But there's a problem here. If you do that as well, what you will have is the two tracks will touch. So the problem here is because this connector is not designed for more than 1 amp. So therefore, by default, those footprints are placed in such a way that it's not meant to be for 6 amp. So what I will have to do is I have to compensate this by reducing this. Hopefully we won't use, the power supply is capable of producing up to 6 amp, but your circuit is not actually pulling 6 amp, maybe maximum 4 amps is doing. So if I look at the calculator again, and then let's say I'm using a 4 amp current, 2.03 millimeter. So if I go for 2.3 millimeter 03 for my worst case scenario, now that probably works really well. Okay. Now if I draw another track here, I just want you to consider this. Now never have 2 tracks parallel, because they will create interference, or the signal jump from one side to another. So what I would prefer you to do is to actually zigzag it up first and then go across, and zigzag it up down here and then go across is a lot better than starting it parallel. Okay, that's something to bear in mind. So all I have to do is click on my node and then change it like this, and then also I've got a node here, and then I can do it like this. Now you might say, sir, is it possible? But did we not say we should avoid as many bands as possible? So yes, correct. So what can I do? I can move the D4 slightly up. Then I don't need the band at all. I can go straight line directly across. So I save bending the wire, the tracks. Okay, but we do have to increase our pads. We'll do that at the end. Okay, in fact, I'll just demonstrate this, how to change the pads. So click on the pads, or the component, I think. Yeah. So you have to select the layer that you are interested in, which is the silk screen, and then click on the pad, and then it will allow you to change your pad size. So it needs to be changed. Parts, 3D data, pads. Let's look for the pads. You can either do it here. There you go. So can you see where it says on the bottom THT pads? You can manually change your pad diameter, but be careful here. You got inner diameter and an outer diameter. Okay. So the inner diameter is a drill diameter. So I believe we have 0.9 millimeter drill bit downstairs, but the pad diameter needs to be increased to slightly bigger than your track. So I'm going to go for, because it's 2 millimeter, I'm going to go for 2.5 millimeter to see if I can just change that for now. Let's see which one I have just changed. Yep, I changed that one. So I need to change the D2. D2 is this one here. So if I change that to 2.5, there we go. So if I zoom in, you can see now the ring is slightly bigger than the tracks. Okay, that's how you do it. Again, on here, because this is telling you which side is the anode and the cathode, that's why it's a square pads. So once again, look at your component D4, find D4 on here, and then change the pad pin J, because it's got a mark of C, pin C. I'm going to change that to also 2.5 millimeter. There you go. So that pad's increased. Okay, but all the holes I'm going to stake to 0.9 millimeter, so then my drill bits can just go through there, nice and easy. Okay, so what I'm going to do, therefore, I'm just going to randomly, I believe they are all in millimeter, so I'm going to change that. So change all of them to 2.5 by selecting them if they have not already been selected. So I'm going to change that to 2.5, and hopefully everything else will change to 2.5 as well. Yep. And then there's some more at the bottom here. 1, 2. Hold the control key and you can select, and then just double click on one of them, and then you can change the 2.5, press enter, it will change the rest to 2.5 as well. And now I can finish drawing my tracks, except this one I need to move it away a little bit. Now again, if you can place your component slightly horizontal, it will change the yellow line to look like a polygon. Can you see? It's go up and across and then down. Now if it's not, it's just a straight line, but it's directly horizontal, it changed to a lines like that. Okay, so now I can draw more tracks. So by default it should yeah, where's my track gone? Or have I? It's not. It's now very thin. So go back to my parts, trace. Oh, my trace clearance is fine. My where's my trace width gone? 2.03 millimeter. Let's see what's going on here. Polygon. Oh, can't be that one. No. Because it's automatic. I'm on the wrong layer. That's something I need to always try and remember. I drawn on the wrong layer, because my layer is to draw copper top, so that's why the tracks was not showing up. So hopefully now it's back to normal. Perfect. Okay, so I'm just going to finish this off now. There. There. And instead of going slightly diagonal, I'm going to slightly move this D6 up a bit, so then it's nice and horizontal. Remember, lines should be perpendicular as much as possible. So I'm just going to try and demonstrate to my examiner that I'm doing at least one that is actually perpendicular to each other. So because the diode D6 tends to get hot, so I want to isolate the component a little bit more. So I'm just going to move it slightly centered, like so. Now I can't seem to, because this is slightly longer than that, so I can only get it to horizontal with either the resistor or the horizontal directly with this one here. So what I'm going to do is I'm going to go directly with this. So I'm going to draw the track again. Done. And then slightly downwards here. And then escape. Draw a line here. Now, I see opportunity to make those two align vertically. So I will now move the R1 slightly like that. And that means I can position this again. But be careful, I think it's created two notes here. So I'm going to delete that and try again. Sometimes the simulator, the Ultiboard is not too smart compared to the human. So I reckon I can do it in one single band, and that's what I will do. There we go. Done. Don't worry about it, it's slightly out, yeah? As long as the ring covers yours, it won't show up in your chemical etching. But this one, we'll need to redo again because it's not quite directly horizontal, it's slightly come down a bit. So again, click on the cursor, select your tracks, delete it. Now guys, if you're not joining in, it's okay. I'm okay with that, okay? Because for me, you and me, we are nearly done, okay? Our time is nearly over, okay? All I would like you to do is just leave, okay? Just let me finish this recording with no background noise, etc., okay? If you're not taking part, you're just sitting here so that you're just showing that you are here, okay? Otherwise, just go. Get your breakfast, go and have a coffee, okay? Because it's no point sitting here at all, okay? So, yeah, please, I'm out you in already, so you can leave, okay? But every time I say that, no one leaves, and they just carry on talking, and that's the problem for me, okay? So, let me finish this. I'm almost done. I've created the whole of Unit 22 CD, nearly all done now. Okay, so I can see I just need to do that bit now. So go down, straight down like this, escape. Now here because I changed the footprint, it gave me a warning message. It would delete my tracks. So that's why it doesn't go, there's no green line. So I'm going to directly connect this to this capacitors, then to this component. Okay, so I'm going to draw. So it's up to you guys. I will align the capacitors. Which way should I align more? Let's go for the top. So I'm going to move these capacitors slightly upwards so that I get a nice straight line. Actually, it's okay. So I'm going to join from here to this position here. Oh, does it let me? Oh, it's not going to let me, is it? Press escape. Good. And then from here, go here, double click. Oh, come on, get in. Yes. And finally, we have these two together. Okay. Now, as I said, I don't like to see two. I don't like to choose transmission line all parallel to each other. So what can I do with that? That is the trouble. So one thing you can do, which is going to improve a bit, is to keep your lines shorter. Okay, it's going to have a problem. Okay, however, alternatively, if you want to, you can cut. It's not a good idea, but it might be better, and you actually bend your lines to get there. Okay, so you keep the lines far away. Okay, either way will give you good. If you justify why you do that, whichever reason, either move your terminal closer or make more bends to avoid the two lines touching each other, that is fine. Notice here is perpendicular, so that's good. This line here is perpendicular to this. The interference will cancel out each other, so it will be okay. All right. So I'm just gonna finish this off using the method that I don't normally do, which is to bend the wire upwards. Now, I think there's depending on your graphics card, sometimes the graphics looks like you've done something wrong, but actually, if you zoom in and out, it will correct your graphics.
Could this work?
It could. So yes, so you can turn this slightly. Yeah, the only thing is, you know, if you look at the side of your laptop, none of your connector will be slightly angled. Are you talking about angling your...
Yeah.
No, well, actually, you can angle your capacitors. Yeah, you can angle your capacitors. That could work. Well, anyway, let's do whatever way your desire tells you. But that's what I'm going to do now. All right, there we go. Done. Now I can just go straight line with that. There's no need for me to go diagonal because I think those two lines are far away enough. So I'm just going to do that. Okay. I am finished. But can anyone tell me I left two mistakes. Oh, no, I left 3 mistakes in there. Which 3 mistakes have I made? James can see it from the front. Can anyone see the mistake here? Yes. So what is it? The pads. The connectors pad. I haven't changed the diameter. Okay. This is too thin anyway, let alone being not big enough. So I need to change the connectors. I don't know why it didn't show up, but so THT pads. So apparently J1, it uses a design rule. So I'm going to overwrite the design rule by clicking here. I'm just going to change that to 2.5. And then 2.5 on this one as well. I just noticed that if you switch this millimeter to millimeter, everything will turn into millimeter. I just noticed that. I probably know this anyway, but I don't always remember from last year's work. So again, 2.5 and 2.5 here. Done. Okay. Oh, we have a problem. If I zoom in, look, too close. This is dangerous. This is this gonna have effect. So therefore, the design rule were right. We have to have a gap. So therefore, I cannot use 2.5 millimeter. As a result of this, because I should be using a different connector for this, so that the 2 pins are wider apart. Or alternatively, you can delete this connector and just simply use a wire sticking up. Okay, you can do it that way, and then you solder your wire to it instead of using a connector. But for now, I'm going to make this connector to be 2 millimeter wide instead, just so that again, if you can explain to your examiner why you do that, that is fine, guys. But make sure you screenshot before and after changes. So this is the before matter. It's too close. Can you see this gap? Okay, 2 things. Chemical etching will not be able to deal with this gap because they're so close. So they will show up as joint. The other thing is it's going to have interference electronically, electromagnetic interference. So therefore, I'm going to change that to 2mm, bang on, which is around the same width of the width of your tray. So I'm going to change them all, okay, and then 2.03, I remember. There we go. Right, that's better. Okay, that is exactly the same width. What about the hole size? Well, apparently the hole size is the width of the pin that you are going to put in it, and that it is 1.18mm. Okay. However, it doesn't stop you to drill a smaller hole size first, but I will leave it. Sometimes you gotta have enough space, enough copper here to allow your soldering, the solder to actually go onto the track. You see, so that's good. Okay, so I need to also change this then. Okay, I don't know why this hasn't been changed. Oh, there it is. I forgot to add that to 2.03. Done. So hopefully that will change now. Give it a sec. There we go. And the capacitors, I definitely would need to change the capacitors as well. For some reason, my capacitors pad diameter, so I'm going to try and change that to, I reckon, 2.03 in the same situation again, because they will be too close to each other. Alternatively, you can find a footprint that has a much further separations if you prefer. But that's what I'm going to do now. I'm just going to change that to 2.03. And then upload this. So now you're ready to go to laser printer and print this mask. So if I go to File, Print, oh, there are still errors. What is the errors? I don't know what errors it's talking about, but I'm just going to File, Print. Just going to continue. And I'm going to print the top only. So not this top, it's the copper top. So copper top, which is that one. And then take the copper bottom away, preview this. There you go. That's the tracks, okay? And that's what you're going to put into your chemical solution for etching. Now looking at this, it looks like I've got a bit of misalignment there, so I might tidy that up before I do it, so I can see that is higher than that, just to make it look a little bit nicer, okay? But remember, this is my input side, this is my output side, because it's in reverse, okay? So Ultiboard is already done the reverse automatically for you, okay? I think so. Yes. Yes, yeah, that's right. That's it. And then when you submit your report, you got to submit this as a PDF as well to show your footprint. And what I would suggest you also do, guys, to save me paper, is I'm going to close this, and I'm going to also add your I think it's called silk screen top as well, so you know which component is which. So I'm gonna go and preview. There you go. So there should be next page as well. You see? Oh, yeah. I pressed the print button. So just in case you don't know, sorry. So copper top, silk screen top, and then press preview, and make sure it's printed at 100%, so there's no scaling up or down. And you can see here, it reminds you of your component and your track. So when you place your component, you can borrow these sheets as well, so then you know which component to put where. Okay, all right, that's it. And you can see how they done the datum for you automatically. So that datum with more lines has to match with this datum when you overlay onto it. Okay, so you see this datum here must match this one. Because normally what we do is we buy a silk ink for PCB. So then you can, not only you can protect your copper before it get oxidized, but also allow you to print the component name onto your circuit. But we don't need to do that in this lesson or assignment. Okay, that's it. I'm going to stop the video. That is, so then you manufacture it and you take it downstairs and you're going to then measure it. Okay, so I've done it in less than 2 lessons from design to finish, and then all you have to do is demonstrate your version and then show me when you're ready to make a mask. I bought a 100 acetate paper and hopefully that should be enough. Okay, only this one will be printed on acetate. Okay, this one I will print for you on the on your actual A4 paper so you can see. Okay, that's it. I'm going to stop the video. Any questions? Yes? Okay.